Let's continue with the chemical properties of the 1,3-oxazolium 5-olate molecules, and this time let's talk about the reaction with some nucleophiles. You can see here and you will be able to recognize that as far as this meso-ionic molecule is concerned, we are trying to carry out its reaction with three different nucleophiles. Namely, the first one is what it is, H2O means water. The second one is ROH, that is our alcohol molecule. And the last is what it is, an amine molecule, that is RNH2. Basically, all these three different nucleophiles, I mean H2O, ROH, as well as the molecule of amine, are what? These are a neutral type of nucleophiles. Let me write here, these are what? These are all neutral type of nucleophiles because they are not carrying any formal charge. Let me write here, it is a neutral nucleophile here, right? So because of the absence of any formal charge, they are considered as neutral type of nucleophiles. Okay, and you can see here that this meso-ionic molecule, that is 1,3-oxazolium 5-olate, upon reaction with all these neutral nucleophiles will be resulting in the formation of three different types of products. The first one is this, the second one will be like this, and this is the last one, that is reaction with the amine as a nucleophile. Okay, so basically what I can say here is that starting from this product up to this one here, we can say that what is happening as we are moving from here to here, it is nothing, it is a sort of a ring opening type of reaction. You can also see here that as far as the first reaction, that is with water, is concerned, the product formed here is what? It is a type of a carboxylic acid molecule because it contains this C double bond OOH after the reaction is over. Okay, so let me write here, a carboxylic acid is the only product of the first reaction, that is with water molecule. In case of the second reaction, that is with alcohol, what we are getting here is, I mean, this thing is what? It is a form of an ester molecule. So we are getting an ester here as the product in the second reaction. And in the last here, what we are getting is a molecule which is generally known as an amide molecule because it contains C double bond O and N atom here, right? So the first product is a carboxylic acid, means meso-ionic, upon reaction with water will yield some sort of carboxylic acid, and the same molecule upon reaction with alcohol will result in the formation of a molecule of ester. And in the last case, that is with amines, it will result in the formation of an amide like this. Okay, so now we can also say that because it is resulting in the cleavage of the ring from here, which I know is known as lysis, Lysis. Lysis means the cleavage of some bond, and because water is doing all this thing, so water means what it means, we can also write here hydro, that means from, it is coming from water. Okay, so basically the first reaction is nothing, it is actually the hydrolysis type of reaction. Let me write here the hydrolysis type of reaction. In the same way, because here instead of water we are using alcohol, but still the cleavage of the bond, that is this C and O bond, is taking place, and because alcohol is responsible for this, so we can better call the second reaction as an alcoholysis type of reaction, means alcohol is carrying out the cleavage of some bond in this reactant molecule. And in the last, because a molecule of amine is being used here for the cleavage, so we can call it as an aminolysis type of reaction. This is what? This is an aminolysis type of reaction. Now, as far as these three nucleophiles are concerned, so we do have some common names of these reactions. The first one is hydrolysis, followed by alcoholysis, and the last is what? It is the aminolysis reaction. And now let's talk about what type of mechanism is involved in all these reactions. Okay, so first of all, you can see here is what it is our 1,3-oxazolium 5-olate meso-ionic molecule. And from the last some lectures, I have told you that we can always write some equivalent structure for our meso-ionics, and it will be like this here, okay, such that the reaction mechanisms will become quite easy to understand if we are starting from such a representation instead of this one here, right? So first of all, let's talk about the very first reaction, that is with, let me write here, a molecule of water, and we used to call it as a hydrolysis reaction, okay. And now, why we are saying that the water molecule here will be cleaving only this bond here and not something else, or not some other bond in this heterocyclic molecule? The reason, the answer is quite simple here, because what we have here is, you can see in this picture, is nothing. It is an organic functional group, and the name is what? It is an ester type of functional group, okay. And now we all have learned this, that in our lower classes, that esters are what? Basically these are the carboxylic acid derivatives. Let me write here the carboxylic acid derivative, okay. So we do have some other carboxylic acid derivatives as well, namely the acid chlorides, if you remember from your lower classes, then is what? It is the acid anhydrides, After that comes the ester molecules, which is our present case, I mean this here. And the last derivative of carboxylic acid is what? It is the molecules of amides, okay. And now why I'm telling you that we have these 4 different kinds of carboxylic acid derivatives, just to make you understand that if we talk about the reactivity of these carboxylic acid derivative molecules, I mean from here to here, these are the carboxylic acid derivatives, and ester, you can see it is one of them, okay. So reactivity wise, the acid chlorides are highly reactive. Then comes the anhydrides, after that esters, and in last we have some stable molecule. They are known as what? The amides, okay. So we can see here from this order of reactivity. Let me write here, this is what, starting from here to here is what? It is the order of reactivity of different carboxylic acid derivatives, order of reactivity, right? So you can see here the esters are present in this order of reactivity, and they are reactive enough to react with water as a nucleophile, right? So because water is a weak nucleophile, so it is not like that it can react with any substrate, okay. So there are some substrates which are reactive enough, only they allow the reaction with these types of neutral nucleophiles. Otherwise it is not possible for water molecule to carry out the hydrolysis of any substrate by itself, until and unless we do have something reactive on the other side, like in this case, okay. So if we are having some amide here instead of ester, which is less reactive than ester, in that case the reaction with water or the hydrolysis with water may not be possible until and unless we are adding something extra in that, some catalyst, I mean, right? So the reaction with water will be like what? That we know the oxygen atom here contains what? It contains 2 lone pair of electrons. The first one and the second one is present here like this, okay. So now what is going to happen is, this carbon atom I'm talking about, this carbon atom will be having a partial positive charge, and this oxygen atom here will be having a partial negative charge, because it is a carbonyl group and oxygen is more electronegative than this carbon atom, right? So this means we do have some electrophilic type of spot in this ester functional group. Now what our oxygen atom, which is having lone pair of electrons, what it can do is it can definitely attack on this carbonyl carbon like a nucleophile, sending these electrons onto this oxygen atom, resulting in the formation of what? It will result in the formation of R1 single bond oxygen here, and the rest of the molecule will be like it is present, means the R3 here, R2, this is having a positive charge, this single bond, then this bond here, this will now become oxygen negative with a single bond, and to this our nucleophile will now be attached something like this here, okay. And obviously because the oxygen, which is basically a divalent atom, is forming 3 bonds here, so we need to put a positive sign here like this, okay. Now as soon as this intermediate is formed, it will be doing 2 things. The first one is these electrons will be shifting back to this carbon and oxygen bond, and these electrons will be going to this oxygen, I mean the cleavage, that is the most important step in this mechanism, will be taking place. This bond here in between the carbon and the oxygen will be going to cleave like this. Moreover, oxygen being electronegative here, it is not happy to have a positive charge. What it can do is it will be releasing a proton from itself by taking both the electrons of this bond towards itself, such that now what is going to happen is it will be releasing H positive ion, I mean this H positive ion, and that will be taken up by this carbon having a negative charge, right? So now what I can write here is the R1 single bond, this oxygen will now be having a negative charge because of the cleavage of this bond from here. As usual, a double bond nitrogen having a positive charge here. This is having the R2 group. This is also attached to this carbon atom having R3, this H positive. Now when it will go to this carbon atom, it will now be present in this way, means one H here will now be present like this, a single bond here, this will now become a double bond oxygen, and this will now become what? A hydroxyl group like this, okay. Now after that, what is going to happen is from the solvent, means the water here, I mean the water, HOH, we know it is weakly acidic in nature. Let me write here weakly acidic. Still, it can do what? It can give H positive ion to this oxygen negative, okay. So this oxygen negative here, it will be taking one H positive ion from the solvent itself, and that is what? It is the water, right? So now the next intermediate will be what? It will be R1 single bond O. This will now become H after taking one H positive from the water, that is the solvent in this reaction. Double bond nitrogen, this is having one R2 also a positive bond as it is. A single bond here, one H, it is also having one R3 substituent, a single bond C, double bond O and OH here, right? Now after that, in the last step, what is going to happen is these electrons of this hydroxyl oxygen atom will be shifting back here like this, sending or satisfying the positive charge on this nitrogen atom, such that now we can write here R1 single bond. This will now become a double bond oxygen. It is also having one H, you can see here. This will now become a single bond nitrogen, to which one R2 group is attached, a single bond. This is the H here as usual, R3, and this is also having a C, double bond O and H here. That is a carboxylic functional group, right? So now, because the positive charge on this nitrogen has now been dispersed, but still we do have something charged atom here, and that is this oxygen atom, because it is forming one pi bond here and two sigma bonds. So I need to show a positive sign in this way here, right? And finally, what is going to happen is it will be releasing one H positive ion, and the driving force here is what? That the oxygen being electronegative, it is never happy to have a positive charge. So now it will do its best to get rid of this positive charge, and the best way here is what? To release a proton from itself, finally resulting in the formation of what? One R1 here, single bond. This will now become a double bond oxygen after removal of a proton. The nitrogen having R2 single bond, this is the H here, this is also having R3, and this is what it is, our C double bond O and OH here, okay. And you can see here, this is what? It's the final product molecule of this hydrolysis reaction, or let us say the very first reaction of our meso-ionic molecule with the neutral nucleophile, that is the universal solvent and water, let us say, okay. So what we are having here is from hydrolysis with water, it is yielding what? It is yielding a type of a carboxylic acid. And what is most important thing in this reaction is what? That the point of cleavage is this point, and it is nothing, this is actually an ester type of functional group, which is a carboxylic acid derivative, and reactivity wise it is at the third slot if we talk about the reactivity, right? So it can definitely react with water without the presence of any catalyst, right? So finally resulting in the formation of a molecule of carboxylic acid, and this is the mechanism here. And after that, a similar type of mechanism will be there as far as the other two reactions are concerned, that is the alcoholysis as well as the aminolysis, okay. So we will be talking about both the reactions. Let us first of all talk about the alcoholysis, means the reaction with alcohol, ROH here, right? So in the same way, water molecule was having oxygen atom containing 2 lone pair of electrons. The same thing is present even in case of alcohol. The only difference is that in place of H here in water, we are having what? We are having some alkyl group here, that is the R group, okay. So once again we do have our ester linkage here that is susceptible to be attacked by nucleophiles, even the neutral ones, right? So that now I can show the attack of this neutral nucleophile on this carbonyl carbon of the ester linkage in the same way we have discussed just on our previous slide, right? And sending these electrons onto this oxygen atom, such that now I can write here R1 single bond, this oxygen here, double bond nitrogen having a positive sign. I'm sorry, I forgot to put a positive sign here. It is having a positive sign, right? So this is also having one R2 substituent, a single bond, R3 here, as usual, the negative charge. And now this will be what? This will now become a single bond oxygen negative after the attack. And here I can show the attacking atom, that is the oxygen bonded to one H and one R group here, right? So now this oxygen here, because it is forming 3 bonds, better to put a positive sign here like this, okay? So after that, what is going to happen is this will be releasing a proton from itself in this way here, and on the same time this negative charge will be shifting here, cleaving this bond from here in this way, right? Such that I can show here the second intermediate of this reaction, and it will be what? It will be oxygen negative here, a double bond nitrogen having the positive charge. This is the R2 here, single bond R3. When it will take H positive from this adjacent OH positive, this will result in the formation of one H bond here, right? And then a single bond. This will now become a double bond oxygen. Moreover, this will be what? This will be oxygen, now a single R group here, okay? And in this way, the positive charge, whatever was present on this oxygen atom, has now been dispersed, right? And after that, what is going to happen is this O negative will be taking the H positive ions from the solvent, and in this case it is what? It is the molecule of alcohol, that is the ROH. These are also what? These are also weakly acidic in nature, right? So it will be giving its H positive ion that will be taken up by this oxygen negative. So that I can now show here the next structure. It will be something like single bond OH here, double bond nitrogen having a positive sign. This is the R2 group here, single bond. One H here, this is the R3 having C double bond oxygen and OR here, right? So as soon as this structure, this intermediate is generated in this reaction, what is going to happen is in the same way, these electrons will shift here, dispersing the positive charge on this nitrogen atom, resulting finally in the formation of R1 single bond, double bond oxygen here, okay? And this will also be having one hydrogen and now a positive sign here, of course. This will now become a single bond, nitrogen having R2, one single bond, H here, R3, and this is what? This is C double bond OOR here, like this, okay? And finally, whatever is formed here, it will be releasing one H positive ion. I can write here minus H positive ion, I mean from here, because oxygen, as I have told you, is electronegative. It don't want to carry a positive charge. So what it will do is it will release a proton, resulting in the formation of what? R1 single bond, double bond oxygen. This will become, yes, this is now nitrogen having R2 single bond. This is what? This is my hydrogen here, R3, and this is C double bond OOR here, like this, okay? So this is the final product of this reaction, and the name of this reaction from here to here is what? Because we are using alcohol as a nucleophile. So as I have told you on the previous slide, it is what? It is an alcoholysis type of reaction, and this is once again the point of cleavage in this ester linkage, finally resulting in the formation of this type of product molecule. And if you take a close look on the structure of this molecule, you will see that it is what? It is also an ester type of molecule, okay? But it is definitely different from the starting ester molecule. So let me write here, it is another ester molecule, okay? And now we do have a name, another name for this reaction, in which one ester gets converted into a second ester. This is also known as trans-esterification reaction. Trans-esterification reaction, right? So in this way, with this alcoholysis, we will get this type of cleavage of this ring from here, resulting in the formation of a molecule of ester. And now we are left with the last reaction, in which the nucleophile is what? It is a molecule of amine, means RNH2 here, right? So in the same way, the attacking atom here is what? Instead of oxygen now, what we are having here is a nitrogen atom, which we know also contain a lone pair of electrons. So the same type of attack will be taking place here on this carbonyl carbon of the ester linkage, sending these electrons in the same way onto this oxygen atom, such that now I can write here one R1 here, means R1 single bond oxygen. This is that same double bond nitrogen having a positive sign, the R2. I mean the rest of the structure will remain exactly same, the negative charge, and this will now become what? Oxygen negative, and this nitrogen after attacking will get attached to the rest of the molecule in this way, means one H here, one R, the second H, and here is the first H on this nitrogen atom. And because it is a trivalent atom, so it is now forming 4 bonds here, so better to show a positive sign here. And like oxygen, the nitrogen here is also electronegative. It is also not happy to have a positive charge. What it will do is it will release one proton from itself, and that will be taken up by this carbanion, means the carbon atom having a negative charge. At the same time, these electrons will be shifting here, cleaving this bond in the same way after shifting of these sigma electrons onto this oxygen atom, such that now I can write here the R1 single bond, double bond, nitrogen here having a positive charge. This is having R2 group. This will now having H and R3 here after abstracting a H positive ion from this part of the molecule. A single bond here, this will now become a double bond oxygen, and it is also having one NH as well as one R here, right? And here what will happen is oxygen negative like this, okay? And in the same way, after abstracting H positive ion from the solvent, what will happen is it will now become R1 single bond OH here, double bond, nitrogen having a positive sign. This is the R2 single bond. This is having H, R3, and as usual the C double bond O, N, H, and R, right? So now, likewise, these electrons will be shifting here, dispersing the positive charge on this nitrogen atom in such a way that what we will get at the end of this reaction is one R1 single bond. This will now become a double bond oxygen, and when this will become a double bond, obviously a positive sign will now be present here in this way, and after releasing one H positive ion from here, I mean what will happen is this will be a single bond nitrogen having R2 here, single bond 1H, in the same way R3 and C double bond O, N, H, and R here, right? So you can definitely recognize the final product of this reaction. It is some sort of amide here, and the name of the reaction is what? Because the nucleophile is an amine molecule, so better to call it as an aminolysis type of reaction, okay? So this is all about this lecture, in which we talked about the reactions of 1,3-oxazolium 5-volate meso-ionic molecules with three different types of nucleophiles. The first one was water, and the name of the reaction was the hydrolysis, in which we used to get what? A molecule of carboxylic acid as the final product, okay? And followed by the second reaction, in which with the use of a molecule of alcohol, and the name of the reaction was alcoholysis, we used to get what? A molecule of another ester, and we do have a second name for such a reaction, that is known as the trans-esterification reaction. And lastly, we carried out the same type of reaction with the third neutral type of nucleophile, which was our amine molecule, finally getting this type of amide molecule. And the mechanism is almost same in all these three reactions, right? So thank you so much.